So I'm just going to record a video today for some of my students that I work with, especially my elementary students who could really understand, I think, prime numbers in a more meaningful way. Typically when students hear about prime numbers, they think about a number that has factors of 1 in the number itself, or with respect to division, it's divisible by the number 1 in itself. But also we can use color tiles or squares to give students a really good visual, conceptual understanding of what prime numbers really look like. So here we go. These are just nothing more than 1-inch squares. Using the grid for a little bit of background here for you. So 1 is neither prime nor composite, so we won't use 1. It's the loneliest number that you'll ever do. And then let's evaluate 2. And we can never connect 2 this way because we can't do vertex to vertex, but we can connect 2 this way. And we change nothing by connecting 2 that way. So 2 is prime. Prime, and the other side will have our composite, PC. So 2 is our first prime. Let's evaluate another number. Let's try 3. Holes are bad, and that represents a gap or a hole. We can't have holes, but we can show 3 this way. Again, we could not show 3 this way, nor could we show 3 that way, right? So here's 3. And 3 is prime. Let's evaluate 4. Wait, 4 is prime also. Not. 4 is composite. 4 is like, hey, I can go this way, 1 4 times, or I can go 2 by 2. Right? So we put 4 on this side. Okay? Any students can quickly understand what we mean by prime and composite numbers with this sort of graphic representation using color tiles, or you can even do it with grid paper without the color tiles if you're coloring. Let's try 5. We know 5 is going to be prime, obviously. 1, 2, 3, 4, and 5. Can't go here. Holes, holes, gaps. So the only place that we can actually place this and be consistent with our rule to have no holes is to have them in a straight line, right? So 5's prime. Okay. Let's try 6. Add one more tile. Nope. 6 is composite. It's a 2 by 3 or a 3 by 2, however you see it. And it's also a 1 by 6. So it's composite. Let's try 7. We know what 7 is going to be. It's going to be composite, or maybe not. We'll see. 6, 7, 7, 7. Let me just do another arrangement here. Maybe I can make it work. Nope. Only way to do 7 is 1 times the number 7 itself. Okay. 8, obviously composite. 2, 4, 6, 8. All right. So we have a 4 by 2 or a 2 by 4. There's 8. A lot of students at this point sometimes think 9 is prime. In fact, it's composite. Makes a perfect square. Right. Also, this is really helpful to understand square roots too, because horizontally you have the quantity of 3, 3, 3, and vertically you have the quantity of 3, 3, 3. And also your diagonals have a quantity of 1, 2, 3, 1, 2, 3, but the lengths are different, right? Pythagorean theorem, but that's something else. So 9 obviously is composite. It's a perfect square. Okay. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and so on, right? So using color tiles, really helpful for you to understand prime and composite numbers. And I'll do more videos on prime and composite numbers, but we'll actually do some factoring and show how they're very, very useful to simplify fractions and do all other sorts of cool things. All right. Thanks a lot. Fear not.